Okay, Assalamualaikum. So today we are going to learn about chapter 6, electricity and magnetism. We need to recall a few things that you have learned in Form 1 and Form 2. Okay, first we take a look at magnetism. Okay, so this is a magnet bar. Kita ada magnet bar. So as you all know, magnet bar consists of two poles. Kita ada north pole and also south pole. Okay, so some of the properties that magnet have is it has magnetic field lines. Okay, dia ada medan magnet, garis medan magnet. Okay, let's say the bar magnet that I have drawn just now. So we have north and south. Okay, so this is the magnetic field lines. Okay, so the magnetic field lines must go from north to south. So bila awak lukis arrow, dia kena daripada north, mesti habis dekat south. And the field lines must not intercept each other. Dia tak boleh langgar-langgar lain-lain. Dia ada laluan dia sendiri. So energy sources can be divided into two. We have renewable sources, which means that the sources can be replaced continually and will never deplete. Maksudnya dia sentiasa ada supply. Dia takkan habis lah. And we also have non-renewable sources, means that sources that cannot be replaced and will deplete. Dia akan habis satu hari nanti. Okay, so renewable sources, for example, solar, okay, matahari, wind, angin, geothermal, gas daripada bawah tanah, haba daripada bawah tanah, biomass, okay, biomass can be sources from plants, it can also be sources from animals. We also have wave and also hydro, air. Non-renewable sources that cannot be replaced, such as nuclear, okay, habis lah, habis guna, habis. Petroleum, coal, natural gas are the power stations in Malaysia. We have in Perak, Sultan Azlan Shah that uses coal. In Sarawak, Bakun Hydroelectric Power Station which uses hydro. In Negeri Sembilan uses natural gas. In Pulau Pinang uses diesel, and in Sabah we use biomass. Actually, there are more power stations all around Malaysia that uses different sources. Okay, semuanya menghasilkan elektrik, semuanya generate electricity, but they use different sources. Okay, so macam mana setiap power station tu menghasilkan electricity, menjana, kita guna perkataan menjana or generate. How the power stations generate electricity? Okay, so the basic the fundamental device in a power station is called generator. Generator ni is a device that used to generate electricity. Ini mesti ada untuk menghasilkan electricity. Okay, so as you can see in this picture, a man cycling. Sebenarnya bila dia cycle tu, dia rotate the tire. Okay, so dia rotate the tire. So what happened here, the rotation here will cause electricity to be generated. Okay, macam mana benda itu berlaku? Okay, we will learn about this later. Ini gambar pertama, we have simple electric circuit where we have bulb, we have switch and battery. Okay, dry cell. Next, in the second picture, we do not have battery. Okay, kita tak ada battery kat sini. But instead, we have generator. This is a simple generator. Ni kita panggil simple generator. Okay, so simple generator is made up of coil wire. Kat sini kita ada coil wire. Dan juga kita ada magnet. Kita ada magnet. Okay, so what happened here is, in picture number 1, kita press je switch button, electricity will flow. Betul? Electricity flow from positive and end in negative terminal. But in 2, what happened here is, kita akan pusingkan roda ini. Bila roda ini berpusing, dia connected to the coil here. So coil here will also rotate. Okay, coil ni pun akan rotate bersama. So there will be interaction between magnetic field from the magnet and the coil. Ada interaction Interaction itu will generate electricity. Okay, next. Electricity that is produced in the second picture we call as induced electric current. Okay, elektrik yang terhasil, yang dijana kita panggil induced electric current. But in picture number 1, kita tak pakai generator, kita just pakai electric. The term is electric current. For picture number 1, the term is electric current je. Okay, but for electricity that is generated, we use induced electric current. Okay, so lepas ni, bila kita sebut induced electric current, it means electricity that is generated, yang dijana. Okay, next. What is induced current? Okay, apa itu induced current? Maksudnya generated lah. Yang tadi tu, maksudnya dia menggunakan generator. Okay, so induced current is current produced in a circuit when there is change in magnetic flux. Okay, bila ada perubahan kepada magnetic flux di dalam satu litar, barulah current akan dihasilkan. Okay, apa itu magnetic flux? Just now you know magnetic field is, tapi magnetic flux kita belum sentuh. Magnetic flux is the number of magnetic field lines in an area. Okay, dalam certain area tu, berapa banyak magnetic field lines kat situ? Banyak ke sikit? Kalau banyak perubahannya, banyaklah current. Okay, okay. So here we have two pictures. Picture 1 and picture 2. In picture, the magnet bar, this is the magnetic field line. Nampak? Ada berapa kat sini? Ada 5. But however, only one magnetic field that interact with the coil. However, there is only one magnetic field here yang warna biru ni interact with the coil kat sini. Okay, cuma ada satu yang interact. So we say that the number of magnetic field lines cutting the coil is 1. Okay, bilangan magnetic field yang interact ataupun term dia dipotong lines cutting the coil is 1. Hanya ada satu sahaja. Okay, whereas in picture number 2, we have 5 magnetic field lines. Semua yang warna biru ni, kita kira ada 5. So, all 5 magnetic field lines are interacting with the coil. Ataupun, term yang betul dia adalah number of magnetic field lines cutting the coil is 5. In the first picture, the lines cutting the coil is 1. Magnetic field line cutting the coil is 1. In the second picture, the magnetic field lines cutting the coil is 5. So, ada tak perubahan di situ? Ada kan? Okay, so this is what we call as change in magnetic flux. Ada perubahan kat situ. Okay, bila jauh, when the magnet bar is further apart, only one line is cut. But when it is near, the lines cutting the coil is 5. So, there is change in magnetic flux. Okay. So, this change of magnetic flux will generate current which we call as induced current. Okay. Okay. So, how does electricity is generated? First, here, like I have explained in the previous page, we have simple generator kat sini which is connected to a bulb. Okay, ada bulb kat sini Okay, so here rotating the crank will induce current in the circuit. Here we have crank here. Bila kita rotate kat sini, the crank is connected to the coil wire. Kat sini kita ada coil wire yang bersambung dengan crank Okay, what happened here? If we zoom in, we have magnet. Here we have magnet bar, north. Here we have magnet bar and north and also south. North and south. Okay, so you know that magnetic field going from north to south, kan? We cannot see, but we know that the magnetic field is there. dia ada kat situ tapi kita tak nampak. Okay, so here, we have coil. Kat dalam ni pula ada wired coil. Okay, so every time the crank rotates, okay, bila ini pusing, when the crank rotates, it will cause the coil wire to rotate as well. Coil wire pun akan rotate. So, bila dia rotate, it will cut the magnetic field lines. Okay. So, kat sini berlakunya cutting of magnetic field lines. Okay, ada pemotongan kat situ. So, the magnetic field lines are being cut by the coil wire when it rotates. Macam mana dia rotate? Because of the crank. Kita rotate crank, kita akan rotate the wire. When we rotate the wire, the magnetic field lines will be cut. Okay, so the cutting of magnetic field lines will generate electricity and produce induced current. Okay, dia akan menghasilkan induced current. Okay, so induced current is produced only when there is cutting of magnetic field lines. Bila ada pemotongan magnetic field lines, barulah akan ada induced current. So, how do you how do you generate induced current? Okay, number one, we have two ways. Number one is moving a straight wire quickly across a magnetic field between two magnets. Okay, so here we have two magnets, one north, another one is south. Here we have two magnets, one north, another one is south. Okay, so there are magnetic fields in between them. We cannot see, but we know it is there. Okay, so here we have wire. Nampak tak yang bergerak atas dan bawah ni? Ini adalah wire. Okay, what happened here is we move the wire up and down. Naik atas, turun bawah. Naik atas, turun bawah. Okay, so this is the cutting of magnetic field. Kita kacau, ibarat potong angin. Okay, macam tak nampak apa-apa, but actually there is interaction kat situ. There is cutting of magnetic field lines. Okay, so if we do this quickly, up and down rapidly, current will be produced in the circuit, in the wire here. Okay, and you can see here the galvanometer, dia deflect ke kiri, ke kanan. Ke kiri, ke kanan. Okay, that shows that current flows in the circuit. Okay, number two, we have moving a permanent magnet towards one end of solenoid. Ini cara kedua to produce induced electric current. Kalau tadi, what we do is, we move the wire. The second method is, we move the magnet. Okay, we move the magnet into the coil wire. Here, the coil wire ni kita panggil solenoid. Okay, coil wire here we call as solenoid. Okay, so what happened here is, the magnetic field lines, bila dia masuk, so more magnetic field lines are being cut. Bila dia interact dengan coil, dia cut.